So starting on page 9, we have Euler's method. Being able to create the table, knowing how to, if they don't give you the step size, knowing how to get to the step size, which is b minus a over n. Sometimes it's possible to have your delta x being negative, especially if we're going backwards, if we're trying to get to a x value that is to the left of where we started. But in this case, going to the right. So you're going to be creating 4 columns here. You have x, a y, a dy dx, and then your y equals y sub 0 plus slope times delta x, which is just going to give you a du, basically just going to be a change in y, because y sub 0 plus change in y. And then we're just working through the table and trying to get to the y value for a specific x. So hopefully we've done enough of Euler's method where you kind of you just know that it's going to be a bit of a tedious process, but it's not difficult as long as we know how to create our table and fill in our chart. Okay, any questions with 9? Number 10, there's a little bit of improper integral here where we have to evaluate a bound involving infinities, but we can just pull that infinity out as b approaches infinity, and then seeing if a value will get to a real number or whether it will go to infinity. Euler's method for part B and part C, solving differential equation, separating the variables, y is on the left, x is on the right, and then solving for y and solving for c. Page 11, we have area, top minus bottom, and then we're rotating around a horizontal axis, but there's a gap, and because of the gap, we know there's going to be Washer method. So it's going to be big R minus little r squared, big R squared minus little r squared in terms of x. And then perimeter of a region, we have to use our arc length formula. We know the portions there are straight lines or diagonal lines. We can kind of just count that. That's just 1. We can count this distance using distance formula, or think of it as hypotenuse of a triangle. We can also think of it that way. And then, but then for the arc portion here, we got to go through the square root of 1 plus f prime squared. So just so to find the perimeter, I'm just adding up all those segments there, the vertical line, the curved line, and then the diagonal line. It's just asking to set up. So this is meant to be a non-calculator course. This is calculator here, but it's not asking for us to set it up. Now, yeah, we do need a calculator to get to this number, right? But we don't have to evaluate further than that.
Don't even need to get to that number, right? You can just do the integral for that number.
That's right. Yeah, just do the integral here.
For the middle one.
Oh, this one here?
Yeah.
That's right. Yeah, you can just leave it in that, not integral, but radical form, right?
Yeah.
Yeah, even radical form, you can.
Yeah. Is the area between curves stuff going to be on the going to be on the quiz next week?
It could, right? With these miscellaneous, it's kind of pulling from some random AB topics.
Okay. Do they alternate during AP exams, or are they guaranteed?
What do you mean?
Do they put them on the exams only some years, or are these guaranteed to show up?
You mean these miscellaneous topics?
Mm-hmm.
I think it's guaranteed that at least 1 or 2 of these will show up in some form on the AP exam, okay. But there won't be a dedicated problem just for these. It'll kind of like these small parts that are inserted into into a smaller problem. Polar area seems to be a bit more fuller problem, but then polar area, the average is once every 2 years. That's when it shows up.
Has it showed up last
year? It hasn't shown up in the past 2 years, so maybe it's due to show up this year. Okay, let's see, page 12, sorry, page Yeah, page 12. Sorry, I didn't get a chance to, I forgot to put a blank copy of the slope field on your blank page, but we just have to follow, we just have to draw the two graphs that follow along the path of your slope field. So this one, you can tell it's a straight line going through that point because that's where it leads. And then it's going to go through this other point here. So we'll create a slope field. We just kind of follow the flow of the graph in building that slope or building the solution curve. Any questions with page 12? And then part D is applying second derivative test. The idea that if my slope is 0 at a point and my graph is also concave down, the combination of slope 0 and concave down is going to ensure there's a relative max because the graph is going to arc down and it's going to have that relative max at the top.
Question on page 2.
Okay.
Part B. I don't know how you came to like the upper bound. I don't understand.
Oh, right here, this
Yeah.
theta here. So we know that theta is some degree measure, right? Or some radian measure. So the only way that we can get to this theta value is using x and y, right? And so the connection between theta and x and y is that tangent of theta is equal to y over x. So I can represent theta this way, make it inverse tangent of y over x. So that's the way we have to connect to it because we don't have a way to get to that angle otherwise.
Okay.
Yeah.
Like, how do you know it starts at 0?
Uh,
I mean, like visually, I can see that, but like sometimes it doesn't always.
well, because it's on the x-axis, right? The shaded region starts on the x-axis and it extends to this line here.
I don't know, like on some polar area problems, I've seen like it hasn't like started there. I don't know how to explain it.
If you can find an example, then we can talk about it. But I think all the ones that I've seen will start at 0. I don't think it will ever start at like, pi over 36, something like that, something like really strange.
I think what I'm referring to is when it doesn't start at 1, it starts at 0.
Or you may have to draw it out for me because I'm not exactly sure what that looks like. Okay. So are we okay up to page 13 is a repeat. So okay, so let's see if we can work through as much as 14 through 19 as we can and go ahead and start there. And I'll walk through problems once you guys had a chance to try it. Okay, so this is non-calculator here, page 14. It's still starting. Yeah, even if it's this, it is still starting at 0 in order to build out. It's just at a very sharp angle. So that's why it's not lining up against the x-axis. Yeah.
calculator question.
Mm.
For a volume revolved around, volume of a solid revolved around X. Can I just like put a decimal answer or do I have to leave the pi? Like,
I like to leave the pi, but if they don't specify, then decimal is fine. It's just sometimes with pi, we can potentially represent our answer in a more accurate form. Right? Yeah, but if our coefficient is already decimal, then that pi is not really making it any more accurate. So, yeah, I think it's a judgment call. I like to leave pi, but I think sometimes you can multiply through and that can be fine. For part C, if this cross section has an area, we know that this rotation is going to create a circle, right? And that circle has a radius of 1 over root x, so it's pi r squared. So I'm taking that area and I'm finding the average value of all the different circles that are created from one end to the other. So that's where that 1 over b minus a is coming from. Average value of the circle. For part D, we're doing improper integral, and we can see that as we are to evaluate, we're going to get a numerator that is basically infinity, which is minus 0, which is going to infinity minus a real number, which is going to be infinity. So the integral is going to diverge. However, the average value will converge because this expression will now be divided by b minus 4. If I do limit as b approaches infinity, all of a sudden the denominator is going at a faster rate than the numerator. And so therefore this will go to 0, this will converge. So the first part of part D diverges, but the second part of part D converges because of that average value, b minus a, the denominator. For page 15, we have a logistic differential equation, and then also solving a differential equation.
You know, page 19 is calculators.
Let's see. Yeah, 19 is calculator. Great, thank you.
What did you? What you both think? That's. Actually just steal it. No, not any, but everything else. Which is. Oh my God, thanks for. Donnie. Cal, great. Well, it's gone. Yeah. I do. John's a hater. That's the point of my best. What's that? You don't show up. You don't show up.
So I know that volume of S is this from.
Wait, you're also kind of gonna cry.
This is my 12 R. I'm saying these equal to each other.
Yeah. I'm really good. Saturday.
Oh, I
didn't. Already.
Yes. It's pretty. Is unbounded, so it's
Into one.
and then it's able to converge to this number. So I'm saying it's
Oh, unbounded means there.
infinite, yeah.
Oh, it's out?
Yeah.
I guess.
I got here today and was like.
That's good.
Yeah.
Yeah, be selling the.
Also, distance math is.
Didn't bring my major out.
Okay, so tomorrow I'm gonna check pages 14 through 19. Guys, come and get your phones.